Welcome back to this series on how to build in Unity. This is episode 4. If you haven't seen the first 3 episodes, it's not really a big deal. We've just created the scene, some things to build, and this Raycaster class. Today we're taking a look at that Raycaster class, and we're going to add some functionality to it. Right now, as you can see, all that we're doing is printing a message that says that if we're hitting the ground, then we're going to print a line that says casting at ground layer. So let's change that and make this a much better class. Let's open that Raycast class. Remember that that's on our main camera. We want to change the Raycast that's being called in the update function. What we want to do is make it so that we're not just casting at the ground layer. We want to cast at all the layers. And then we'll create some properties in this class so that we can give useful information to all the other classes that are going to reference this one. Now I'm going to create a member variable of a Raycast hit. I'm doing this here so that we don't have too many garbage collections. Since we're always doing this on update, we don't really have to allow the garbage collector to take it away. Now what I'm doing here is I'm going to eliminate this parentheses, this open parentheses, so that I can see the signatures on that Raycast function. Now I'm just hitting the up and down arrows to see the different signatures here, and I'm going to use one of the signatures that uses the Raycast hit struct. So we're going to pass in that hit struct that we have here, that hit member variable, and if we get a hit, that hit variable is going to be filled with some very useful information. So let's open up these brackets, and if we get a hit, what we're going to do is print the name of the object that we hit. So again, on that hit variable, we have access to the collider that we hit, which gives us access to the game object, which gives us access to that game object's name. So we're going to print the name of the object that we hit. Let's save. Let's go into play mode and see if that's working. So you're going to see that we're already hitting the object that's called the ground, and now we're going to go over these trees, and each tree obviously has a different name, and as we hit them, it's going to print the names. Now, we're able to hit these trees because of their box colliders. That Raycast doesn't work if they don't have a collider, as you can see here. Now I'm going to turn those colliders back on, and now it prints their names again. Great. At this point, I think it's time for us to start building for the first time. So what I'm going to do is say that if we hit something, and if it's on the ground layer, then I'm gonna want to build something. Okay. Now, that's saying, as it is right now, we're saying that it's going to build every single frame, and we obviously don't want that. So instead of doing that, we'll also need to give it some input, as in when we click on the left mouse button. So let's go ahead and add some input here. So we're going to say input.get mouse button down, and if we press 0 here, that's the left mouse button. So we're saying that if we clicked on the left mouse button and the object that we hit is on the ground layer, then we're going to do something called create primitive, and that's just going to create the basic cube that you get when you right click in the hierarchy and create a new 3D object. Okay, there's a problem here. All right, this is going to work. This is going to create those cubes. However, they aren't going to be where we expect them to be because I haven't moved that cube to the point at which we clicked. So we'll do that here. We're going to store a scoped reference here of the game object. We're going to call that game object O, and we're going to say that after we create it, we're going to move its position to the position of the mouse click. Now, what you might think is that we have to go in here and say, okay, let's find out where the mouse is based on where it is on the screen and turn it into a world point, but we don't have to do that because we have that Raycast hit object that we created before. Like I said, that's got some really useful information on it, such as the hit.point. That is the point at which this Raycast made contact with a collider. All right, and you can see that right here. So we'll use that, and as we point and click, we're going to create objects on that point at which we've clicked. As you can see here, we're going to go in here. That's perfect. We'll just click, and we're creating a cube everywhere that we click that's on the ground layer. So as you see, I'm trying to click on these trees, and because they're on the building layer, we're not creating anything. Perfect. Let's save. Now it's time to clean up this Raycaster class and take out this prototyping building, because we don't want the Raycaster to be responsible for input or building. So we can pass some useful information with this class, and off of this hit collider we can pass the layer, for example, that we've struck. If we do strike a layer in the raycast method, we can pass positional information if we hit something, right? So with that hit point, we can pass the position at which a ray hit a collider. The first thing I'm going to do then is create a public int, which is returning an int. Okay, I'm going to call this get hit layer. So if we have a collider, if we've struck a collider, then we're going to pass the layer on which that collider exists. Now the way that I'm doing this is a little bit different. Instead of saying if hit collider does not equal null, what I'm going to do here is use the ternary operator after a logical expression. So here's the logical expression. Hit.collider does not equal null. Then I've got the ternary operator, the question mark, and to the right of that I've got what's going to be passed if true, and to the right of that I've got the else, or what's going to happen if that's not true. Okay, so I'll set that up here with a little bit, right? So that question mark is if this hit collider game object layer is what happens, then otherwise, right, after the colon we've got the else, and that's -1. So we're passing in invalid layer with that -1. Now we're going to give access to the positional data provided from hit.point. So I'm doing the same thing as before. I'm creating a public vector3 called get hit position. I'm using that same expression that I did before, right? I'm using that same logical expression. If we've got a collider, if we've hit a collider on the last frame, then we're going to pass the hit.point position data. Otherwise, we're going to pass vector3.0. With these two properties, get hit layer and get hit position, we're going to be able to do a lot with the rest of our classes. Okay. In the next video, we're going to take this stuff, this building stuff, out of update here, and we're going to put it into a build manager class.